Okay, so let's take a look at calculating the average for the selected students on the Ravens team. This is looking at the data, and I compare that to the previous team. There's not a lot of deviation, not a lot of variation here. Okay, so we would expect that the standard deviation for this data set is going to be lower. But before we can do the standard deviation, we need to get the average for this data set. So we'll add up all of the heights, and we'll notice once again that the sum of the data, x, is 1,155. So we'll notice that the average height for these players is exactly the same. So there's no difference in the average height for the two teams of 7 girls. It's 165 centimeters. So we'll start to calculate the standard deviation. So we're looking at taking all of our data values and subtracting the average, which we just found. So we have 166 for Sam, and we're taking away 165. So we just have that she's 1 centimeter above average. Shannon, 163, take away 165, so she's shorter than average by 2 centimeters, so that's -2. Okay, so for the rest of this, I will continue to just write the answers. We already have 2 sample calculations, so that should be enough. So 3 centimeters above average, 4 centimeters above average. Maria is exactly the average height, and the next 2 students are 1 centimeter taller than average. Okay, so our next step is to square all of these values. Okay, so this is the procedure for the standard deviation. You calculate your deviations, and then you square them all. So we'll have 1 squared, right? So yes, of course, that's 1. We have -2 squared. We have +4. Remember, the idea here is that we have all positive values. You're squaring a negative number. Of course, you're going to get a positive value. So we showed 2 sample calculations, so that is enough, and we'll calculate what the sum of the squared deviations are right here. Okay, so just adding up all of these values, okay, we find that that works out to 32. Okay, so we now have enough that we can, I'm just going to bring that down here, calculate what the standard deviation is. Okay, so we're just going to rewrite that again. We have the sum of x minus x bar all squared, and we're going to divide that by the sample size -1, so that's n-1. And remember, we're going to take the square root. Okay, so that's the whole next step. Okay, this is referred to as the standard deviation. We use S for the standard deviation, which wasn't mentioned previously. Okay, so we have 32, and we're dividing that by 6, and we're going to take the square root of that, and of course we get a much smaller standard deviation because there was less variability in these students' heights. Okay, so when we look at comparing now, these students can be described as having a height of 165 centimeters, but with a plus or minus less range on average. Recall the other team had quite a bit of variability, and we looked at their average height being the same, but there was a lot more deviation at 15.9 rather than 2.9 centimeters. So standard deviation looks like it is a complicated formula, but as long as you follow the procedure, that is calculate the deviation, square them, use the table to do that, add them up, and then in another area outside the table, divide by the sample size less 1, and take the square root to bring the scale back down. Okay, so you will need a lot of practice with this, so make sure you complete all of the homework questions that have been assigned so that you're prepared for when we have a quiz and a unit test for this material.